All right, people, here we go. Number 16, simple and compound interest. Fun stuff. So we're going to get into some more kind of financial literacy kind of stuff here, right? Um, how much do you need to put into account to get a certain amount at the end is really what we're thinking about here. Okay. Um, So we've done these before, right? Future value. I put money in now. How much is it worth at the end, right? What we're going to do now is flip it, and we're going to find the present value of something. Okay. So basically, if I want a certain amount, how much do I need to put in now? I need $100,000 for college. How much should I put in my bank account now? Okay. That's present value. Okay. How much do I need to put in now to get a certain amount later? If you want to write that there, it's not a bad idea. Okay. So these formulas give that to you in three different ways: simple interest, compound interest, and continuous compounding. Simple interest, I don't know if we've talked about it yet, is it's the interest rate, it's the interest you would do with like grandma, right? If grandma gave you a loan of $200, she'd be like, yeah, just pay me like 10 bucks a year until you can pay it off, right? It would be simple, right? 10 bucks a year, boom, 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 go, right? Um, Compound interest, it's compounding, right? You're multiplying by a certain thing each time and it's growing exponentially or it's shrinking exponentially, right? It's exponential growth or decay. Same with continuous compounding. Simple interest is linear, okay? Adding $10 every year, right? Grandma gives you, I don't know, or you give grandma $200 after a year, she owes you 210. After 2 years, she owes you 220. After 3 years, she owes you 230. Come on, grandma, pay up 240, 250, right? That's simple interest. Okay. Does that make sense? Okay, good. Effective rate is we know that simple interest has that same like rate, right? It's 5% a year or 10% a year. But when we start compounding things, it's actually better than just simple interest, right? This at 5% a year is 5% per year growth, right? This, when you start compounding by months or that kind of stuff, days, constantly compounding, we're getting better than that rate. So this tells us effectively what is our rate, right? The rate might say 5% annual, but we're actually getting 5.1% because of the compounding helping us out. Okay, dokies. So that's what we're going to be doing here. Here's all the information. A lot of this is the same, a couple little twists to this one. P is the principal or present value. That's the amount at the start. Okay. A is the future of maturity value, future or maturity value. That's the amount at the end. At the end of the period, how much do you have? Annual interest rate is still as a decimal, just like it was before. Number of years, since we're dealing with financial stuff, that's it. Number of compounding periods per year is now M. So that's a little different. Okay. It's a little different for these formula up here. I is interest rate per period. Okay, so to find that out, so to find out I, you take R and divide it by M, which makes sense. If the overall interest rate is 10% and you're compounding twice, 10 divided by 2 would give you 5% per period. Okie dokie. N is the total number of compounding periods, and that's going to be M times T. Okay, M is the number of compounds, T is the number of years. So if you're compounding twice a year for 10 years, 2 times 10 is 20. You would be compounding 20 total times. Okay, so these are a little different. R of E is the effective rate, and we see that in the formulas for it. So that's effectively, this is my annual percentage rate that I'm getting effectively because of the compounding helping it out. Cool. Cool. All right. So all we're going to do is we are going to we're going to have some examples and we're going to use these formula up here. That's it. Okay. So it's important to know if we're using simple, compounder, compounded, or continuously, right? In the questions, I make it clear as well. How much will you have to put in account giving 5% simple interest? So I'm going to go simple interest and use one of these two. If you want 20,000. So how much do I have to put in? Okay. So that's present value, right? How much to put in? How much? I'm going to write it here now. How much to put in? And this is the one I use. So I don't know that, so I'm going to use that. P is equal to how much do we have at the end? If you want 20,000. So that's going to go on top. On the bottom is 1 plus the interest rate as a decimal. So 0.05 is 5% times time, just 5. Okay. I'm going to put that in my calculator. That's 20,000 over 1.25. Boom, that's 1,600. Okay. I could figure out, let's find 5% of that. So times 0.05. So the simple interest would be $800 a month. So 1,600 plus 800. That's 1 year, 2 year. Oops, I didn't do it. Plus 800, 2 year, 3 year, 4 year, 5 year. Got me to 20,000. There we go. Easy peasy. All right, let's stick with simple interest. It says, I borrow $500 from my dad. He tells me I will owe him $575 in 6 months. What interest rate is he charging me using simple interest? Okay, so I'm going to use this formula. I could use either one technically. For this problem here, I could have just plugged stuff into here and then divided and did some algebra and gotten the same thing. It wouldn't be very hard. Okay. So you could plug it into either. Don't flip out, right? If you're like, I don't know which one to put it into, put it in one or the other and then solve for what you don't know. You'll be okay. This one I'm going to put into present value. So I borrow $500 from my dad. I will owe him 575. So which one is what is present? That's the 500. Sorry, is that right? Yeah, I think so. 500. I think so. Yeah. Yeah. Present is equal to 575 over 1 plus, I don't know the rate. So, but I do know the time is half a year. So 0.5 times the rate. Okay. I'm going to multiply both sides by the denominator. I could have used this one, might have been a little easier, but that's okay. Multiply both sides by the 1.5r. 1 plus 0.5 r. Then I'm going to distribute here. So that's going to be 500 plus half of that is 250 times r is equal to 575. I'm going to subtract, oh, can you see this? Sorry. I'm going to subtract 500 from both sides. So I get 250 e times r. Try that again. 250r is equal to 75, and then 75 divided by 250. And that is zero point 0.3 or 30% is the interest rate he is charging me. Dad, that's kind of rough, dude. That's more than like some really bad credit cards, right? Let's see if it works. Let's go 0.3, 30% times 500. So if I let it for a whole year, I would owe him $150 in interest, right? But it's only half a year, so we'll divide that by two, $75. So that makes sense, right? $75 in interest. Dad, that's mean, dude. Come on, bro. All right, compound. How much will you have to put in account giving 5% annual interest compounded quarterly if you want 20,000 after 5 years? So I don't know, but I'm doing compounded quarterly, right? So M is going to be equal to 4. That's going to be key. My formula is right up here. I can use either of these. I don't want to use this negative. That scares me. So we're going to go a over 1 plus I to the n. So I'm going to just write down the formula. All right. How much do I have to put in? That's the P. That's what I'm trying to find out. My A is the at the end. So that's going to be 20,000. My one is a one, my plus, my I need to figure that out. What did I represent? I'm going to look up here. Interest rate per period. So I is R over M. So I is equal to R over M. In this case, it's 5% divided by 4. So 0.05 over 4. So that's going to be 0.125. I could use my calculator for that if I need to. And then this is going to be to the n. And what is n? Total number of compounds. N is m times t. N is equal to m times the time, which is 5 years. So that's 20. So it's going to be to the 20th power. Cool. Cool. All right. So let's plug that in. That looks like 20,000 divided by 1.125 raised to the 20th. Yeah. Oh, that doesn't look right. Oh, Mr. Rebuff, I see where it is. 0.125. So 0.05 divided by 4 is 0.0125. I was going to say, that doesn't look right, right? That doesn't look right. Going from less than 2,000 to 20,000 in 5 years, I knew something was wrong. Let's try that again. 20,000 divided by 1.0125. If you were yelling at the screen, go, Mr. Repop, you forgot a zero. You're right. Ah, that looks better. 1560.17. 1560.17 dollars. All right, 15,000. That kind of makes more sense, right? I put about 16,000 in. After 5 years, 5% interest, I've got $20,000. I could plug this back into the interest formula to check. It's not a terrible idea. All right, let's take that amount. Let's multiply it by 1.0125 to the 20th power, and that should get us back to 20,000. It did. Perfect. All right, effective rate. Okay, we're in compound interest, compounded quarterly, so we're going to use this one right here. So let's write it down. RE, the effective rate, is equal to 1 plus R over M to the M minus 1. Okay, so I'm just copying down what I have up here. Copy that down here, and then let's fill it in. We already have all the M's and the R's and all that good stuff, right? Um, Cool, cool. All right, so let's go. This is going to be 1 plus 0.05 over interest rate over M. Why didn't they just say 1 plus I? Over point over 4. And then that's going to be to the mth, which is 4. How many? It's number of compounds per year. So that's going to be to the 4th. And then we're going to subtract 1. There we go. All right, let's do it. So 1 plus 0.05 divided, oops, sorry, divided by 4 equals, we're going to raise that to the 4th, and then we're going to subtract 1. So our effective rate, 0.0509, is about 5.09%. Okay, so basically each year we're getting about 5.1%. Okay, even though it's advertised as 5%, because of the compounding quarterly, this is helping me out a little bit. It's giving me that a little extra juice, right? All right, good stuff. Last one, compounded continuously. So now we are into these right here, those formulas. How much will you have to put in account? Giving 5% annual interest, compounded continuously if you want 20,000 after 5 years. Okay, so we're going to use the top right, but down one formula. P equals A over E to the RT. Okay, basically, you see what this is. We're just solving A equals PERT for the P, right? We divided both sides by the ERT. All right, so let's plug it in. A is equal to, um, let's see, where am I? I don't even know. Oh, my A is how much I want at the end. So that's 20,000. over E, and that E is going to be raised to the R, which is the interest rate, 0.05, times T, which is 5 years. So this is just 20,000 divided by E to the 0.25. Plug it right into my calculator. There we go, 15,576. And 2 cents. There we go. So check this out. Same idea as this, compounded quarterly, compounded continuously. To get 20,000 continuously, I have to put in about $24 less at the start than I would if it was compounded quarterly. Compounded continuously is more better. All right. What is the effective rate? Okay, so we're going to come up here to the formula right there. The rate effectivo right there, right? E to the R minus 1. Oops, E to the R minus 1. Minus 1's on the outside. So that's going to be E to the 0.05 minus 1. Seems so simple. Can that be right? E to the 0.05 minus 1. Enter. There we go, 5.13%. Right? See? It's a little better, more better, right? There we go. So, some fun there, some present value, some future value, effective rates, all stuff that you'll see if you go into a bank, um, what bank tellers are doing as they're doing their thing. So, there we go. All right. Peace out.